Hello and welcome to this video on using decision tree hands-on using Scikit-Learn. So we'll go into the code and working with the heaters dataset, which we have talked about already in the theory session, so that you may be able to relate what we have talked about in the theory session and into this coding session here. Without further ado, I will show you where the dataset is, and then afterwards we'll go into the code and start coding. Here I am in the ISLR homepage, and inside of the resources, you find the resources here, and you go into pick just this ISL with R second edition, but you could probably pick another one. Under the datasets, download all CSV files as zip. Inside there is a heaters.csv, and pick that one. So let's move into the code now. So here I am in the code. Let's start with the terminal. So uvvnv to create a virtual environment, source.ven bin activated, then uv pip install pandas, scikit-learn. We need seaborn. Seaborn will give us matplotlib, pandas will give us numpy. And then we will need another package for creating the visualization of, I think GraphViz maybe. We'll see. We'll start with this one. Then IPyKernel, of course, for Jupyter Notebook. So start here. So it's finished. UV is amazing. Okay, so let's create our decision tree.ipnd. So here, decision tree, change this to Python like this. Okay, so now we can start. So start with importing some stuff. So import pandas as pd, import matplotlib.pyplot as plt, import numpy as np, import seaborn as sns, and then df equals pd.read csv. We need to read this heaters.csv, and then we do df.head to see the dataset. Okay, first time takes a little bit more of time, and that is totally fine. Then we can do other things while waiting. df info, df dot, yeah, okay. So here you can see this is how the dataset looks like. We have different features, and then we have the output as the salary. Here some of the salaries are none, as you can see here. As you can see here in the info, you can also see that salary. We have some none. However, with the none in the salary, we cannot do anything because it's the target is the one that we want to predict. So we'll do a simple thing to drop it. So drop na, and drop na in place equals true. This means that we will mutate the data frame directly. So if I do df.info now, you can see that we have 263 because it removes all the rows with null values. As we saw before, it was only the salary that had null values, but it removed all the rows that had this null salary. Okay, so after this one, it's time to do some simple EDA, so exploratory data analysis. And let's start with a scatterplot. So sns.scatterplot, data equals df, x equals to years. We'll do the same as the one in the theory, which I drew by hand, but here we'll see how it looks like. So y is hits. And when it's hits, you see it like this. So it looked similar to the one that I drew in the theory. Then we have hue equals to salary. Here you can see the salary. Instead of what I did in the theory, for simplicity, I made it as binary, either high salary or low salary. But here you can see there's actually a range here. So you can see the darker colors are the higher salaries. while the lighter colors are lower salaries. Okay, so this is a neat way to explore the data to see how it looks like. So you can see that most of the salary actually falls into the range of the lower salary category. Let us continue here to do the decision tree now. This is just a very short EDA. What we could do more is I will move on to a decision. In this lecture, we'll just go through the very, very simple of using decision tree. So I won't be using so many features because it's much easier to visualize when we have fewer features to see how it looks like from Scikit-Learn. Because this is where we'll pick our algorithm, import decision. So it's classifier or regressor. So you can see it's continuous values, then it's a regressor. From Scikit-Learn.model selection, import train test split. Then we do model tree regression equals the decision tree regressor. Here I will pick max depth. So to stop this one, I'll pick it as 2 so that we can visualize this. So then x, y equals df. I will pick out just the ones that we looked at. So years and hits. The target is the salary. So these are the ones that I will pick here because I will want to visualize this one. And then I'll just copy from the lecture code here for doing the split because I don't want to mess that up. So we do train test split there, and we can take a look into xtrain.shape, xtest.shape. You can see here, okay, 210 is in the train and 53 in the test. Okay, then we'll do a scatter plot. We will move on to taking a look into y-test actually, and take a look into the histogram to see how it looks like. As you can see here, the distribution is still the same as before, that we have most salary within the lower range, and you can see that in y-train as well. You can see in y-train is also similar distribution, that most are in the lower range and a few in the higher range of the salary. So that is important to know, that when we do train test split, the distribution is still the same, but we just have fewer samples in the testing. So when we just take a look into this one, we can also take a look into sns.scatterplot again. Data equals to xtrain. And we can take a look into the years. Y equals to hits. And then hue equals to salary. Oh, we don't have salary because we only look into X and we only look into the train here now. You see it still looks similar. So we will still use the X train to divide. If you've seen in theory that we divided into 3 regions, and this will happen now as well. So let's continue now with doing the regression. We have model tree reg.fit as normal. Note that in a decision tree, we don't scale the data as we're just finding the threshold. So we don't need to scale the data. So xtrain, ytrain. And then we can take a look into model tree reg.feature importances. And we'll take a look into model tree reg dot feature names in, let me see if that is the case. Yeah, exactly. So here you can see, let me make it a little bit clearer. Let me print this actually to this print. Yes. So here you have years as this one and then hits as this one. So here years are more important. Years are the, as you remember, it's the experience, how much years of experience we have, and number of hits is the number of hits we get. So we can see that the years are more important. And let's go on to Scikit-Learn, import tree. We'll take a look into the plotting now. So this is quite interesting. So fig, x equals to plt.subplots 1 fig size equals to, let me just plot it first and then we'll take a look into fig size. So tree.plot tree, model tree reg, field equals true. We'll take a look, x equals to x. This is how it looks like. Okay, starting now, we'll make the fig size a little bit bigger. 16,8. Yeah, great. Now it looks better. DPI equals 150. Yes, yeah, it looks clear. Take semicolon to not show the text there. Okay, so based on this one, this is quite interesting. So you can see here that we have x0 less than equal 4.5. x of 0, we know it's the first feature. X of 1 is the second feature. So x of 0 is the years, right? And x of 1 is the hits. And then we have squared error. Remember that this is the one that we want to minimize. So we minimize the squared error RSS. We're minimizing it. So it shows here that it's this high, and from this one it's lower, and then it's even lower. So that is the idea, that we're splitting it based on a greedy. We're building our tree based on this greedy algorithm of which one is the smallest squared error that we can find right now. So that is the idea when you're doing the regression tree. Now we want to go into just how to interpret this. So we'll go into feature names, list. I'll pick x.columns. So then we have the x here. We see, let's see. Okay. We have, let me see more. We want to have the impurity. Remember that when it's classification, we talk about the purity of the nodes. Basically, here is the squared error that we have in terms of regression. So we take impurity as false. So you see that that one disappears. And we can make the shapes a little bit nicer. So rounded equals to true. Okay. Semicolon. So it looks like this. We can do like this. So fig.save fig. Let's see what is this called. Decision tree diagram.png. Yes, you can have it here. Cool. So based on this figure, you can see that, okay, so we have 210 samples in the first region. We have less than 4.5 years. This is our first split. And the value is basically the mean value of all those samples, the mean salary. And then we look into if it's smaller than years, so it's true, then it splits again. It looks into, okay, because it's minimizing the RSS. So less than 3.5 years, it's splitting again. We see that, okay, for this region, we have 70 samples and the value here is this much. Then we split it again if it's true or if it's false. Then we split it again to the terminal nodes here. So these are the internal nodes, and here are the terminal nodes or the leaves. Here you can see we're splitting on the hits, because when this is false, we continue to split on the hits. When the years are larger than 4.5, we split on the hits, etc. You can see the number of samples. So based on this one, you can go back to see how it actually does the regression. You can see that, okay, how do you come up with this value 472? It's because we have splitted it in these regions here, and you fall into the region where the mean of the samples is this much. You can see the last region here, the one with the top salary. You can see it's where we have more hits than 117.5, and we have more than 4.5 years experience, then we have this high salary region. So you can see it's quite interpretable, this decision trees. So it's quite interesting to use it to understand how you split the data. However, it's not very good for its prediction is not very good. That is the unfortunate part of it. In terms of interpretability, when it's very important, then decision tree plays a big role. However, it's not working very well in many cases. Instead, when you go further, you will see a continuation on how to use decision tree to build on more advanced algorithms such as random forest and XGBoost. These are just combination of many decision trees in order to make the learning much more efficient. So we have more, it's called ensemble learning. We'll go into that later on. But let's continue with this tree. We can do tree.export text actually. Then we can do model tree reg and feature names equals to list of xtrain.columns. You can see this, it will print this out quite nicely. Here you can see the different splitting that happens if you want to see it in text. So let's move on here with from sklearn.metrics. Take a look into the metrics, import mean absolute error and mean squared error. Then we'll do ypred equals to model tree reg dot predict on x test. Then we can take a look into mean absolute error of y test, y pred, and we'll take a look into mean squared error. We'll do np dot square root of this one and take a look into this. Let me see, np dot square root. All right, we need to take a y test, y pred. Okay, then you get these values here. As before, we should compare these towards other regression models. Okay, so let's move on very quickly to using decision tree for classification. It's quite similar. So decision tree for classification. And here I will pick the default dataset. So for classification, we use the default dataset. This one also picked from ISLR homepage. So from where you downloaded the all CSV files, you have the default as well. For this one, I'll just make it very quickly. So df equals to pd.readcsv. And here we have default.csv. Then we'll go into, we need to do df equals to pd.getDummies. df, drop first equals true. That is because we have worked with this dataset before, and it has, if you look into this one, it has yes and no. Then we need to do drop. We need to use the dummies, and we'll take df of default. Let's see, default, yes. Student, yes. We'll take equals to, we'll make them into ints. So df of, I'll just copy this one, then take .as type, then df.head to look how it looks like. Yes, perfect, it's 0 and 1. Okay, now it's time to divide this. So when we do dummies as before, we don't, when we do one hot and we get default yes and default no, then when you do dummies, you just keep one of them. So when it's 0, it means that it's default no. When this is 0, it's not student. That is how it works. Then we'll do x comma y. Let's see. Yeah, x comma y equals to df.drop default yes. Axis equals 1. Then we'll have df default yes as the y. And then we'll do a train test split. I'll just copy this one. like this. So you have train test split. And then we'll do classification. So from sklearn.tree import decision tree classifier, as this is classification now. And from sklearn.metrics import classification report. We need to have confusion matrix. We need to have confusion matrix display. And then we'll do classifier equals to decision tree classifier. And we'll have classifier dot fit x train and then xy train. Then when you fitted it, you'll do pred equals to classification dot predict and on x test. Then you will do print classification report of y test and y pred. And then you'll do cm equals to confusion matrix. And confusion matrix y test, y pred. And then you'll do confusion matrix display on cm and then dot plot. And voila, it's done. So I won't go through all of this again, since I've talked about the metrics in previous videos. But as you've seen here is that for 0, it's quite high because we have mostly negative samples. While for the positive ones, we don't get very high, except for when we're talking about accuracy, then it's quite high. But as for unbalanced data set, accuracy is not a good metric at all. Okay, as you can see here, most of them were negative and we have some positive, but we're missing the positive with this model. So it's not very good on this default data set. As you've seen, it's quite challenging to work with the default data set. What do you do when it's unbalanced? However, we just want to show how the decision tree works in this lecture. So we've seen the decision tree for regression and for classification. Okay, so in this video we have worked with the decision tree and we have worked with that hands-on using Scikit-Learn and in the code. Then we have worked with it in regression case and in classification, CART, remember that, classification and regression tree. So we have done some exploratory data analysis on the HITES dataset, which you can connect back to the theory session, and we looked into how the decision tree were building its tree. That was quite interesting. You can see how the interpretability is quite high in it. Basically, the decision tree, you can see it as a lot of different if statements, so when to split the different trees. But I hope that you have learned a lot from this video and know that the decision tree by itself is not very, very good as a predictive model. However, you use it to build more better algorithms such as random forest and XGBoost. So this is very good to learn the theory about decision tree and how it works. So thank you for watching this video and see you in the next one. Bye.